which is the binomial theorem. Most of you will probably prefer yesterday's lesson to the binomial theorem. It actually doesn't matter, I just show you both. So in case you would forget how to do Pascal's triangle, you could use the binomial theorem in place of it. But on your test, it will say, the questions will say, expand either using Pascal's triangle or the binomial theorem. You'll get to pick. Now on the back, we will learn some probability problems using combinations and such that will require you to use this theorem, but you won't have to necessarily on your test. So you can also use combinations to help you find the terms of a binomial expansion. And again, this would be in place of Pascal's triangle. So find the values of all of these combinations. 4C0, 4C1, 4C2, 4C3, and 4C4 using your calculator, and see what you notice about those numbers. Going from 4 combination 0 all the way to 4 combination 4. What do we get? What do we notice? What the numbers? Abby?
It's the same pattern as the triangle.
Good. Should have gotten 1, 4, 6, and then 4, 1, which would be the same thing as the 4th row of Pascal's triangle. So the binomial theorem essentially says if you were to not remember how to start Pascal's triangle or to complete it, you can use combinations to find out what the coefficients are by taking combinations starting with choosing 0 all the way to choosing the last number, and that's why they use n. So they have n to the nth power, so it starts out with n combination 0 all the way down to n combination n for any quantity. So we'll do example 5 using the binomial theorem, but then if we want for 6, we can go back to Pascal's triangle because most of you will prefer Pascal's triangle. So for this one, it's a 5th power. Again, if you were using Pascal's triangle, you would just write down the numbers that you know to be the coefficients. Using the binomial theorem, you would actually choose that it would be 5 combination 0. And then this would start out with v to the 5th plus 5 combination 1, v to the 4th, w to the 1st. So again, the v variables are going to decrease in exponent value. The w variables will increase as we go through. Plus 5c2, v cubed, w squared, plus 5c3, v squared, w cubed, plus 5c4, v w to the 4th, and lastly, plus 5c5, w to the 5th. And then, of course, we can use our calculator to evaluate each of those. Oops. We will get 1, 5, 10, and then we know it'll go 5, 1. So again, Pascal's triangle, the same as row 5. So I personally don't use the binomial theorem because I like Pascal's triangle better. I like to memorize those first probably 4 lines, and then you can just use them. But this is a way, if you were to forget Pascal's triangle, that you could come up with these. So it would be 1 v to the 5th plus 5 v to the 4th w plus 10 v cubed w squared Now in the next one, we do have actual numbers. Instead of a and b or v and w, we have variables and numbers. So again, you're going to do this as if it were a plus b to the 3rd. We'll do one more with the binomial theorem. So this would be 3c0 a cubed plus 3c1 a squared b plus 3c2 a b squared and plus 3c3 b cubed, if this were a's and b's. And then we can substitute in that our a variable is actually c, and our b variable, make sure you plug in a -2. Pay attention to your signs when you square or cube them. So 3c0 is going to get me 1. A cubed would be c cubed. Three c1 will get us 3. A cubed will be c, or excuse me, a squared will be c squared. And we do have to plug in a -2 here. I'm going to use parentheses so you don't think it's a -2. 3c2 will also be 3. A is then c to the first, and then this will be -2 squared. Plugging in our value for b. And then lastly, 3c3 will be 1. And b cubed would be -2 cubed, evaluating. And then from here you want to square, cube, raise all those powers, and then you want to multiply them by the leading coefficient. So this one, we're just going to multiply the 3 and the -2 together to get a -6. In the next term, you do have to square this first, so -2 times -2 is a +4, and then we multiply the 3 and the 4 together to get a +12c. And the last one, we need to evaluate our -2 to the third. And again, some of you will type this in your, those of you that are relying on your calculator, be very careful. If you type this in, it will tell you, this isn't a good example. This one would be a good example. If you do -2 squared in your calculator, it will tell you -4. It's really +4. So if you're someone who types everything in your calculator, you have to use parentheses before you square it. That way it'll get you the right value. This one will be actually -8 because it's an odd power. And so that'll be all right. So you guys can try number 7 on your own. Getting for number 7, and if you did the binomial theorem, you did 4c0 all the way down to 4c1, 4c4, or you could have just done the 4th row of your binomial theorem. Again, when it's a negative y, it acts just like a positive y. The only thing that happens is that you are going to alternate those signs, positive, negative, positive, negative. And that's because you're really cubing a negative y, which then gets you a minus. All right, on the back, we're going to take a look at some probability problems. You do not have to memorize the formula back here, but you will need to know what the variables stand for and how and when to plug them in. So the binomial theorem can be used to solve probability problems. And these problems, you'll notice that they talk about the percent or probability of getting being successful at making a shot, making a throw.
Excuse the interruption. Josh Consul, could you please report to the Welcome Center? Josh Consul to the Welcome Center. Thank you.
So suppose an event has a probability of success, and that's your P variable, and a probability of failure, which will be your Q variable. Each term in the expansion of P plus Q to the n power will represent a probability. Now the formula that we'll see looks like this. Okay, so we'll be using combinations. And what it will stand for in this example, let's look at what the variables stand for first. So n is going to be our number of total possible events. R is going to be the number of successes that we want. So do we want to make 7 out of 10 shots, 8 out of 10 shots? How many successes are we looking to have? And then just like we talked about up here, P represents the probability of success, and Q will represent the probability of failure. All right, so in this case we have 10C2, so 10 would be the number of total, 2 would be the number of successes. So this would be 2 successes in 10 total attempts or tries. They didn't tell us what the problem's about up there, so. Again, I'll give you this formula on any problems you'll have on your test, but you will have to know what to plug in and where. So a professional basketball player's probability of success on any single shot is 90%. Okay, so you may want to just keep a little listing of all your variables. You have an N variable, an R, a P, and a Q. So probability of success is our P variable. Now you do have to change it back to a decimal. So 90% would be 0.9 or 0.90. Now you have to actually calculate the probability of failure. If you are going to make the shot 90% of the time, what's the percent that you won't make the shot, that you will fail, Garrett? 10%, which would be 0.1. So you always have to take your 100% minus your success rate to figure out what your failure is. They don't give you the failure. If they give you the failure, then they don't give you the success. You usually find one of the two. Then they say, find the probability that she will make exactly 9 out of 10 consecutive free throws. So 10 is our total. 9 is how many we're looking to make. So again, this is our total. Number of successes we want to occur, our probability of success, and our probability of failure. And then we just substitute into our formula, which is NCR times P to the R power times Q to the N minus R power. And then we'll use our calculator to evaluate. So we should have 10C9 times P, which is 0.9. I usually use parentheses around these, to the R power, which is the 9th power. Not to be confused with my Q. Q is our probability of failure, which is 0.1. And this will be to the N minus R power. So this is our 10 minus 9, which will then be to the first power. These will always add back up to get you N, the exponents. And then this all goes into our calculator. And you can type it all in one row. You don't have to do multiple inputs. So 10, go to our combinations, 9, and then just put a time sign after it, and parentheses 0.9, caret 9, times parentheses 0.1, caret 1. You really don't have to raise to the first power. And we should get this. Now, we have to then convert this back to a probability. So to convert it back to a percent, we just move that decimal 2 spaces, or you can multiply by 100, and we'll get approximately 38.7%. Okay, same problem, so we're just adding on. So the only thing we're going to change here is the N and the R. So the probability of success is remaining the same. Probability of failure is staying the same. We want to see what's the probability that she will make 10 of 10. If her percent of success is 90% and her percent of failure is still 0.1. So everything's going to stay the same except for the this will become 10C10. These will become 0.9 to the 10th power, And then this will become 0.1 to the 10 minus 10 power, which would be the 0 power. We'll input that in our calculator. And again, we'll change that back to a percent. So multiply by 100, or move your decimal space, choose spaces. See if you guys can try C.